Alright guys, today we're still going to be looking at how do we graph and analyze quadratic functions, but we're going to be looking more at how do we graph them and then how do we analyze them. Let's go ahead and jump into it and look at my first example. Let's say I give you this function, y is equal to x squared plus 2x plus 3. I know that it's a quadratic function because it has a power or exponent of 2. Next thing I notice is that this is in standard form because it's ax squared plus bx plus c. So a is 1, b is 2, and c is 3. Well, the first thing I want to do is I want to convert this into vertex form. That way I can better graph it and analyze it. So if I were to convert this, the first thing I do is identify a, b, and c, which I did. So now let's find h. h is negative b over 2a. So since b is 2, negative b will be negative 2 over 2 times 1, so that will be negative 2 over 2, so that will be negative 1. To find k, we're going to plug that negative 1 in for x. And if I plug this into my calculator, I should get a value of 2. So I can write my vertex form. It's going to be y is equal to ax minus h squared plus k. So I'm going to have 1 x minus a negative 1, so that's going to be x plus 1 squared plus 2. And so there is my vertex form. Now, since this is in vertex form, I can easily identify what my vertex is going to be. My vertex, remember, is h comma k. Well, h we found was negative 1, k we found was 2. So if you notice, h is always the opposite of what's inside the parentheses, and k is always the other number. So my vertex is at negative 1, 2. My axis of symmetry is x is equal to h. So in this case, it will be x is equal to negative 1. And then finally, I know that my parabola is going to open up. The reason is because a is positive. A is positive 1. If a would have been negative 1, then I would have known it was open down. So I can sketch this graph pretty easily with all that information. My vertex is at negative 1, 2, so there it is, and it opens up. So I know it's going to open up just like that, through that. Alright, so now I can even do some more things about it. Since there's my axis of symmetry, and there's my vertex is at negative 1, 2. So first of all, I notice that my graph is decreasing from negative infinity to negative 1, and then my graph is increasing from negative 1 to infinity. I also know that there's a minimum. My minimum is 2, y is equal to 2, right there. It doesn't have a maximum, so no maximum. The domain is all real numbers, so from negative infinity to positive infinity. And my range is, my lowest number is 2, so from 2 to infinity. Alright, x-intercepts, well, there are none, so that means when I talk about the zeros, that means my answers are imaginary, so I don't have any real answers. Finally, to find the y-intercept, even though I don't see it exactly on my graph, I do know that my graph is going to hit the y-axis. The formula for the y-intercept is just simply 0, comma c. And so in this case, we said c was 3, so my y-intercept is going to be 0, comma 3. All right, that's it for that example. Let's look at one more. All right, let's take a look at this one. All right, for this one, again, identify a, b, and c. So a is negative 1, b is negative 6, and c is negative 4. Let's figure out the value for h. h is negative b over 2a, so that's going to give me 6 over 2 times negative 1, or 6 over negative 2, so that's negative 3. To find k, I'm going to plug negative 3 in for x. Be careful with your signs. Plug that into the calculator, and that gives me 5. So my vertex form is y equals negative 1x plus 3 squared plus 5. Alright, with that being said, now I can identify my vertex. My vertex is hk. Remember, take the opposite of what's in the parentheses, so that would be negative 3, 5. My AOS is x is equal to h, so that would be x equals negative 3. And then this one doesn't open up, it opens down because a is negative. So let me draw this graph. So my vertex is at negative 3, 1, 2, 3, 5, 1, 2, 3, 4, 5. So negative 3, 5, and I know it opens down. It's not a perfect graph, but at least I know that's what it kind of looks like. Alright, now I do know that x-intercept wise, it does hit the x-axis twice. So I'm going to have 2 x-intercepts. I don't know exactly where they are, but I'm going to teach you how to find them on a later day. For my y-intercept, remember the formula for y-intercept is simply 0, comma c. So that means my answer is going to be 0, comma -4, since we said c was -4. My zeros, I do know that I'm going to have two zeros because I have two x-intercepts, and they're both going to be real. My y-intercept we found. I noticed that it is increasing from -infinity to my axis of symmetry, or my vertex. This is the point -3, 5. So it's increasing from -infinity to -3. Then it's decreasing from -3 on to infinity. My domain is still all real numbers, so -infinity to +infinity. And my range is from -infinity, because it keeps on going down, up to its maximum of 5. So from -infinity to 5. And this does have a maximum. The maximum value is 5, and it occurs at the vertex. All right, that's it for today's lesson.